Like I said, previous studies were pointing to a flat universe. For example, by looking at the geometry of gigantic triangles defined by the largest of the speckles in the CMB. The curvature measured was consistent with being zero, flat, but there's always a degree of uncertainty due to the imperfect nature of any measurement. The curvature could have been very slightly positive or very slightly negative, just as the surface of the Earth appears flat if you're standing on the ground. It's only when you get some elevation that you see the curvature. Just as the surface of the Earth appears flat if you're standing on the ground. It's only when you get some elevation that you see the curvature.
He wasn't sure if it was round or flat yet, okay? Now, how many of you in here have flown in an airplane, a commercial airplane? Okay, you have been higher than him. Okay, and yeah, so if you calculate how high you were, let's go, an average, you can see about, if you see the numbers right over here, 245 miles would be your radius. So right there is from the commercial airplane, okay? Now, people that believe there's a round Earth, when they hear somebody that says they're a flat Earth, they say, get on an airplane and look out the window. Is what they say, okay? But if you get on an airplane, look out the window, you're only seeing this much of the horizon, right? And when you look out, those windows are actually curved a little bit, so it's possible that they're distorting that. But you're only seeing this much right here, right? So it kind of looks like it's curved. But I would say that if you were standing at the altitude where that airplane is, and you were to look 360 degrees, what would the horizon look like?
Still flat.
It would look flat. You won't see the curve of the Earth. Okay? How about if we go a little bit higher now? There was a gentleman a couple years ago by the name of Felix Baumgartner. He did a Red Bull thing. He was sponsored by Red Bull. Does anybody know what we're talking about?
Jumped out.
Jumped out of what?
Hot air balloon?
A hot air balloon. He put himself in a spacesuit, Aiden Shutter. He put himself in a spacesuit. I can't remember what gas they used. And they put him into a space capsule. They hooked it to a balloon, and then they let it go.
And that dude who jumped out of a perfectly good balloon, what's his name? Felix Baumgartner. He would have been about 2 millimeters above the surface of this globe.
This video is used by the community of flat Earth people to prove that the Earth is flat. Okay? Because if you look out the window, what do you see? The horizon is flat. It's flat. Okay? And if he's standing outside the capsule, you can look here. Now it looks like it's curved, doesn't it? Right?
It's because the walls work.
Okay, because not the wall. This is actually because of the cameras. The GoPro fisheye camera, right? And that kind of warps things. But I would testify that if you were standing right here and you look, oops, sorry about that, and you were on this plane right here where the Earth is, and if you were to look 360 degrees, what would the horizon look like?
Still flat.
It would look flat. The horizon would look flat. Okay? So the flat earthers are correct. You cannot see the curve of the Earth from this height.
Wow, he's in space. Look at that. No, he's not. At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat. That stuff is flat.
It's flat. Flip back over, Mr. Johnson. Oh, I got it here. I got it. So, Mr. Felix Baumgartner, this is him right here. Let's calculate where he went. Boom. This is what he could see right here. That was his horizon line right there. Okay? Now, he did it not over the island in Mexico. He did it over New Mexico. That's where he did the jump. Okay, so if we take that same circle and we put it over New Mexico, this is what you see. Can you see any ocean? No, you can't see any ocean. Okay, so that's why you can't see the oceans, is because the horizon wasn't big enough for you to be able to see the horizon, the ocean. Okay, but I will agree with all the flat earthers that no matter where you are on the planet Earth, or even above the planet Earth, you can't see the curve of the Earth.
Etc. Where
Oh, okay. So if the Earth were actually this size, the International Space Station would be orbiting about 1/2 inch above the surface.
Okay, now, one last one. Let's all, for the sake of argument, pretend that the International Space Station is real. Okay? Now, the flat Earth community said it's fake. It's not real. The round Earth community said, yeah, it's up there. I see it at night when it's going over my head, right? Okay, so let's just all pretend that it's real. Let's say we are at the elevation of the International Space Station. They're about 250 miles above the Earth, okay? And let's say we're sitting right at that point, right there at 250 miles. If we calculate the horizon line for the International Space Station, it's about 1,400 miles. It's that much right there, okay? Now, does that show you the entire Earth?
No.
No, it just shows you a section of the Earth, right? And if you're sitting at that point, looking 360 degrees, what would the horizon look like?
Still flat.
It would look flat, wouldn't it? In fact,
The photographs come back and they're rounded.
well, that's because they're looking through fisheye lenses, so it kind of warps things, right? And when you see those pictures, it's usually only a fragment of the circle, right? If you're only looking at this much of it. But if you were to see the whole 360, it would be a circle, right? Not only that, Mr. Joslin and I did some calculations. We took a scale model, and we scaled down the Earth right here, okay? So this is the Earth, a 10-inch Earth. And then he took, Mr. Joslin took all of those horizon line, right? He calculated them and made them to scale on here. So right here, this black dot right here, that's Felix Baumgartner, the guy that jumped from 24 miles up. That's how much he could see, okay? All of the circles are too small for me to cut anything off of here, right? So let's take the International Space Station. Right here is the International Space Station's horizon line, okay? If you take a sphere and you slice it off, what shape do you get? What shape do you get? You get a circle, right? And then if we take that chunk of the Earth right here, and we set that down on a flat surface, what is it going to be?
Flat.
It's going to be flat, right? That circle is going to be flat. Is that true? Do we all agree on that? Okay, so we can all agree that no matter where you are on the planet Earth, even as high as the International Space Station, the horizon is going to look what?
Flat.
Flat.
You'd think that with the beautiful photographs that we have of our round blue planet, it would convince any doubters.